Welcome to the 2017 question B2. This is an intersecting planes question. So you've got the image on the right. It shows a playground unit incorporating two planar surfaces which intersect as shown to represent the bow of a boat. Okay, so we've got our front of our boat there. The unit also includes a triangular seat and two circular portholes. So we've got our porthole here, you just about see one there, and our triangular seat. So figure 2 shows our plan and our elevation. The horizontal and vertical coordinates for the intersecting planes A, B, C, D and A, B, E, F are shown. So we've got our out, up, down. So first off, they want us to draw the plan and elevation of the two intersecting planes A, B, C and A, B, E, F. Okay, so let's use our coordinates to do that. So from the edge of my page, I'm coming across 105. That's A, 135. So this 35. Okay, because my thing has got no measurements there, so I'm just come around 105 plus 30. Okay, so that's B. Okay, C is 195, so that's C. 185 for D. 145 for E, and 135 for F. So F and E. Okay, so that's those measurements accounted for. Now I'm going to go up and down. So I like to just put my 10 mil there because it saves me time. So A is right there on the ground line. B is up 10. So over to B, up 10. Sorry, up 60, down 10. So up 60 for B and down 10. That's B, B. C is up 20 and down 100. So put that down to the bottom there. Up 20, down 100. C, C. D, we're going 0 and 110. 110. D, and G right there. E is up 20, down 50, 20, down 50. So E and F is 0, 60, so 0 and then down 60, which is down to 40. And A, sorry, I forgot about A, is down 40. There's A. Okay, so I can now draw my elevation and plan of both of those. So some of this I'm seeing that I'm going to have to draw the hidden details soon, so I'm just going to go light there now. Just turn my light. Just brighten it a bit. Into F. B. AB, B to C, to D, so B across here to E, down to there. Okay, so those are my planes ABC, so ABCD, and ABEF in both positions. So E there. Right, so first that's completed. I want to determine the dihedral angle between the planes. So the line of intersection between both of these planes is AB. It's the shared line between them. Okay, so here's our line of intersection, So we need to get, first of all, the true length of that line and then see it as a point view. So I'm going to take an auxiliary looking perpendicular, auxiliary elevation. Sliding set squares. Oh, that's at 45 degrees potentially. Make life a little bit easier for us. Does that make sense? 30. Yeah, it's 45 degrees. Okay, so come out here, draw my x1, y1, and project up all of these points. My x1, y1, and my heights then, because I'm projecting from plan, creating an auxiliary elevation. My heights come from the elevation. So B is that height, so follow B down. A is going to be on the ground. A, D and F are also on the ground, so D and F, D, F, and then E and C are actually at the same height. Same height there. So let's follow them down, and that's C and E. So that's AB, true length line. B back to C and E. F and D. Okay, so both of those they're in line with each other. Yes, both of those surfaces. Strong, heavy base. Okay, so next up I want to find the true length . Yes, that's true length. Sorry, I want to find a point view of my true length. So slide and set squares again. I'm going to create an auxiliary looking along that. Here's my x1, y1, or x2, y2. I'll project out. And they're actually parallel. Project out there. Okay. So I got two views back. So you can see here the distance for A and B back to my plan is the same. So that's where I'm going to be taking my distances from. So AB that's A comma B. C. There. D is actually also there. And then stand down here for F and E, which are the same lengths too. So that is EF. C, D. Okay, so that is the dihedral angle, and that's my point view. Okay, so I'll measure my dihedral angle. And I have that at 70 degrees. Okay, so dihedral found. Part C then, determine the true shape of surface ABCD. On the true shape, we want to find a circle with diameter 20 and a porthole. So we're going to find these portholes that they spoke about, and they're giving us the location of them. Okay, so I'll get to that in a second. First off, I need to find the true shape. So before I can find the true shape, I need to find it as an edge view. So let's look here. I actually have an edge view of that plane ABCD. I have an edge view of that already. So I could take an auxiliary. That's one way of doing it, taking the third auxiliary, so looking out, taking my distances back here. Or I could rotate it, okay? I'm going to rotate it. So I've done enough of auxiliaries here. I'm going to show the examiner another skill, so I'm going to rotate. So imagine this is my edge here. So edge view of an object, okay, and I'm rotating it around. So now when I look down on top of it in this view, I see it as a true shape. So rotate. So it's parallel to my plane. And let's project that back to my auxiliary elevation. Okay, so that is the plane, it's being rotated around, so it's going to be like a mirror image of it, so it's being rotated kind of like that, around like that. So let's project that as if it's being rotated. So they're overlapping a small bit, but that's okay. So this is the true shape of that surface. Right, and they want to find a circle, right, diameter 20, so we need to find the center of that. So the center is 30 from line AB. So from the line AB, it's 30 millimeters away, and then from D, so we've rotated D down. Is that point D? That point. Sorry, should have finished after that. So that's point C rotated. D. So this is our true shape. Just go a little bit heavier so you can see it. Okay, so it's 30 away from AB and it's 50 from D, so we can swing an arc length 50 from D. So let's first off measure perpendicular distance . So that is 30. Okay, so I'll compass to radius 50 from D. So that's the center of my porthole, and the porthole is diameter 20, so that's radius 10. Okay. So that's part C completed. And lastly, the midpoint of lines AB, AD, and AF define the oblique plane which contains the seats. So halfway along this line, halfway along this line, and halfway along this line is the position of the seat. And I can find that in any of the views. Okay, probably the easiest would be up in elevation. So let's bisect to find the position of those. AB, I'll bisect that. That's the center of that. We're going to find the center AF. It's very tight, but I have it. And then the center of AD. AD I think only has 20 millimeters between, so it's probably 10, but I'll just show the examiner that I've bisected between AD. Yeah, it's bang there in the middle. Okay, so that's the oblique plane. Draw it in elevation and in plan. So that's the projections of that plane. Find it in plan then. Right. So on AB, here's the center of AB. There's the center of AF. There is the center of AB. So draw that in heavy now. That's my seat. That's that plane. And now we want to, oh, we forgot it's 5 mm off the ground. Okay, so I'm going to measure up 5 millimeters. Find that plane shortened. So there of that seat. Okay, and I'll show the hidden detail to you. Hidden detail running from A. Okay, so that's projections of the seat drawn in elevation and plan. That's what they're looking for, and they want us to determine and indicate the horizontal and vertical traces of this oblique plane. So the horizontal trace is where this oblique plane hits the floor, okay, and we can see, or hits the horizontal plane. So that's where it strikes the ground or the horizontal plane. It strikes it here also. We find projections into that. So actually use a colour here to highlight it. Okay, so that's my HT. And for my V2, so we'll say horizontal section in the same position, so parallel to my HT. It's too short. Parallel from, here's the top corner of it, of that oblique plane, so let's project it up until it hits the vertical plane, across, and that is done as a horizontal section. So this is my VT. Okay, so tick that off also. Right, so that was our intersecting planes question, along with a bit of oblique planes in that question in 2017.